The stage is yours.
Thanks. Good morning, everyone. My name is Rafał. I'm a software engineer at Whatnot. And today I want to talk about a journey, our exciting journey from nerve-wracking days of manual deployment to seamless automatic continuous deployments. But before we dive in, I'm very curious how many of you have heard about Whatnot or visited our stand. Cool. So Whatnot is a live shopping platform and a marketplace where you could buy, sell, and engage in real time in various categories like comic books, for instance. And we're on a mission to redefine commerce, creating a unique blend of community and entertainment. For example, here you can see an auction of a comic book going on. On the first side, there's not much going on because just the comic book takes the center stage. But if you take a closer look, you can see bids going on. Someone wins the auction. Eventually, buyers and the seller engage in chat. We're also one of the fastest growing startups in the US. Last year, our team has grown to 400 members, over 150 of which is the engineering department. And initially, our deployments were very ad hoc. When the team was small, that was fine. Whenever a team member needed to do a deployment, they just did that. But with time, as a team grown, this required a lot of coordination, like asking your peers, hey, your changes in main, am I fine to deploy it? So to improve this process, we changed it a little bit. And now there was a release manager on shift. Every day, twice a day, in the morning and the afternoon, the assigned release manager looked through all the services, all the changes, and deployed all the stuff that needed to be deployed. But again, as the number of changes in a single release grown, so has the burden of the release manager that had to carry if things went wrong. So our release notes looked more or less like this with every single release. And because the author of particular changes is the one that has the best context about the changes that are being deployed, we decided we're going 100% continuous deployment. Merging to main means that inevitably these changes are going to production. And when our release notes look more like this, there's also lower risk of certain things going wrong, for certain deployments going wrong when it goes live. So let's take a quick look at the high-level schematics of our system. On the client side, we have iOS and Android app as long as web app. On the backend side, the main two services that are client-facing as the main backend, crafted in Python. There's live service written in Elixir. The main difference between these two is the main backend serves mostly the synchronous requests, like fetching the feed of shows that are recommended for you, while live service is responsible for more asynchronous operations like chats bits that you have seen in the animation. And we use Kubernetes as a tool to orchestrate our deployments. And if we look at the service, at the stateless service like main backend in Python, what we do to run this continuous deployment, we can do something like that. The client, the user, fetches the feed of the live shows. It fetches it from one of the four available pods. Which one exactly doesn't matter. The load balancer makes that decision. In parallel, we deploy a separate cluster of a new version. We run some synthetic tests to verify its functionality. When we say it's okay, we tell the load balancer, okay, now please serve requests from the other cluster. And when the user fetches the feed again, they do it from the updated version. And after some time, we can phase out the old version. The colors of the pods are not incidental. The strategy called is blue-green deployment. That's something we cannot currently use in the live service that's written in Elixir, because that requires the pod, or at least the whole cluster of pods, with one recent version to be completely stateless or independent of one another. And this is not the case in our alive service. I'll try to explain why in a second. So we have the user. User enters alive, opens a WebSocket connection to one of the pods. This means a process, an Elixir process, with Phoenix channel is created on the same pod, and we utilize Phoenix channels with one channel per live stream. And then Phoenix pops up mechanism, make sure that all the events for a single live stream are distributed across the cluster. Now let's suppose this same user is a seller and they start an auction that you have seen that when the comic book was auctioned. Another process is started in the cluster for that specific auction. Ideally, we would like to avoid having a process for this, but we need to have it for, there needs to be something to keep track of time of the auction and the auction and process the order post-auction. And for that, we utilize a library called Horde. And this process doesn't necessarily need to run on the same pod that the user is connected to. It's up to Horde where to start it. So now let's say we start a new pod. We want to update a version. We start a new pod with the new version. After some time, it connects to the airline cluster. And this top right pod running the auction process is the one that has been selected for termination. So it gets disconnected from the cluster, and what Horde does now, it detects, okay, this process is not longer in the cluster, we need to migrate it somewhere. And it will migrate it to some other pod. This process repeats until all of the pods are running a new version. So strategy called rolling deployment. And in theory, everything should be transparent to the user. The auction should, the user shouldn't notice that something changed while they were running the auction. That's theory. In practice, we have seen when we were running deployment, a lot of times that, I don't know, either this timer went down to 0, auction never ended, or user had problems with bidding, swiping the bid button. This happened a lot, especially during the afternoon deployment that coincided with higher traffic, up to a point where we make a tactical decision to postpone those afternoon deployments. And we had to take a closer look what's going on. If we want to go do the continuous deployment, we need to fix that. So our hypothesis was that we don't know what it is, but if we try to reduce the number of processes migrating during deployment, we'll see what happens. And that's what we did. When the pod opens or joins the cluster, it does that by finding out where are the other pods using the library called libcluster. They do it by making a DNS query, fetching the list of pod IPs and connecting to them. So going back to this example, the pod with the new version starts up, it makes a DNS query, finds the cluster, connects to the cluster. With some other configuration in Horde, this process might already proactively move to this new pod. But keep in mind that this pods running the old version also run this DNS query periodically, and they see, okay, I'm not seeing this new pod on the IP list, but it's connected, so I should disconnect it. And what Horde does now, okay, the auction process is not running in the cluster, so I need to migrate it back. And this can happen a few dozen times during the whole deployment. So that's a lot of migration. And just this, and we made a band-aid fix, just making sure that relying on the DNS query only to connect the new nodes, and letting Erlang distributed protocol decide when to disconnect them. And this was a great success because the problem still happened, but it was it happened much more often, to a point where we decided to resume the afternoon deployments. It still happened, so we know, okay, we cannot do continuous deployment yet, because that will happen. We just don't know when. When we're paid on PagerDuty, we'll know that when it will happen. So how do we detect that if we don't want to go through auctions and wait for this to happen? We decided to replicate it one-to-one. So replicating the whole deployment process and trying to catch it there. And because we're already using Docker images for deployment, we could have just written an Elixir test for that. As a setup, we just make sure we build 2 images, one for the current version that's running in production, one for the release candidate, and we can write a test that, in particular here, user can bid during version upgrade. So we start 2 nodes, both running the old version, and connect the seller that starts a live stream. Then this user starts an auction, and this auction starts on the first node, and the user is connected to the second node. Then we stop the first node and restart the first node, but with the new version. We expect the auction process to be migrated. Then we connect 2 buyers, one to the pod running the old version and one running the new version. First of the users, so the one connected to the new version bids. We make sure that both buyers and seller receive that bid. We do the same thing, but with the user connected to the old version, making sure that everyone received the bid, and let the time run out and make sure the auction ended. So this test exactly tests what we have trying to make sure is fine in production. Right? We do the deployment, at the same time the auction is not interrupted. It completes, users can bid. And at the beginning, remember here I said the auction process will end up on node 1. I lied, because it can as well end up on node 2. It's up to Horde to decide where it ends up. It's based on some hashing algorithm. And in fact, when we ran those tests, it failed only around 40% of the time, which was great. It didn't consistently fail, but in cases like this, there was nothing to fail because there was never any migration. Failing in 40% of cases on your local machine is much better than waiting for a deployment and hoping that you're actually on that auction that will fail, on livestream that will have an auction that will fail. So this helped us to narrow down the issue. And we by rerunning this test and looking for different things, we were able to see that the problem was actually in the Horde library. Not only in the Horde library, but in the library underneath called Delta CRDT, that Horde is using for distributed key value store. And if we didn't know, again, we didn't know exactly what that was, but we knew it's somewhere there. So we decided to write a test on the Horde library level. So we create, as a setup, we create 3 replicas, we connect them to one another. And then we write a test trying to replicate the scenario. We write key value to replica 1, we stop it gracefully, and we expect that replicas 2 and 3 will have the key value in memory stored. And turns out that simple test was exactly what pointed out what the root cause of the problem was. To explain why and what fixed that, I need to go a little bit deeper into how delta CRDT library replicates data between nodes, but not going into too much detail. But I need to introduce the miracle trees. So let's say we have two replicas. On the left hand side, there is a map AABBCC. On the right hand side, there's a map without the CC entry. And how does Horde compare these two replicas? Going from the root node, we compare the hashes. They're different. If they were the same, we would assume both these trees are equivalent. Both nodes have the same state, but they differ. So we need to go one level down. One level down. 13 on the right-hand side is equivalent in both trees, so this means this subtree is the same. On the left-hand side, 2 and 13 are differ, so we need to go even deeper. And we're already on the leaf node, so we can say, okay, C is the entry that's on the left-hand side, but not in the right-hand side. In reality, this tree is much bigger because it's subject to hash collisions. The only thing I wanted to point out here in this example is that the process of synchronization is multi-step. That's the only important thing because that's where the problem was. So when the delta CRD process terminates, it only completes the one round trip of comparing these two states. And as it turned out, there was even a to-do about it in the library. So initially, we wanted to make sure that the whole sequence completes. We thought of for a while, for a day or two, and then we decided that a much more feasible option for us would be simply to, in that case, just to synchronize the whole state. Because it was much simpler for us. By the way, we have it in our fork. It's feasible just for us. Well, not just for us, but the number of auctions we have at any given point is up to 300. They are very short auctions, so the number of processes running the cluster is pretty small. If that was 300,000, that would not be a feasible option. So that was a great, and it fixed that. It fixed everything. We were able to that unblock the whole problem behind going full CD on the live service. We had to improve a few more things related to CI/CD pipeline efficiency, especially the flaky tests. So the ones that either fail because the test expectations is wrong, or the code is wrong but fails just sometimes. And I found out there's a Datadog integration to track basically everything about tests. Only thing you need to do is to send it JUnit test results in the JUnit format. So we spent some time on unflaking all the existing tests, and now we just get a notification on Slack when a flaky test is detected. So what's the real benefit of continuous deployment? Is it just for better development experience and making a single deployment less risky? We believe it's much better. It's much more than that. It's for most importantly delivering value to the users quickly, echoing one of our core principles: always listen to customers. And I want to conclude this presentation with a real life example. I hope that sound works. Real life example from Whatnot that even a very simple change can have a very profound impact on the customer experience.
Please, though, if engineers are going to take one thing away from this conversation, all right? Did the winner draw? Congrats. Move the pending tab. Please. I have to use my arrow keys to get over to it.
He's
Put the pending tab right here. That's more important to me.
Tab to the
Oh my
left-hand
God, you
side.
did! Oh, yo! Legendary! That is such a good change. Thank you. Did you do that for the whole app? Let's go. Can I get a W for Whatnot actually listening to everybody? They're honestly an amazing platform. I would recommend it. Buyers and sellers always taken care of. No cap. Let's go.
If you didn't hear, he was very excited about the change we made with the pending tab. But the thing is that it was made within, someone was on the live stream and was able to make that change, and it was automatically deployed. So if you're passionate about making changes that reach users very quickly, we're hiring as a QR code for a greenhouse board, and we also have a stand next to the exit door. We'd love for you to come to talk to us. Thank you.
Thank you. Applause. Yay.